Hello, this is section 5.4 parabolas. We already learned parabolas before, like a quadratic functions. Actually, when we draw as a graph, becomes a parabolas. But we're gonna approach it a little bit different way this time. So objectives for this section is number one, standard form of the equation of the parabola, but which is it's gonna be a little different than what we used to use. And graphing parabola, which is we're gonna grab a little bit different way too, and find the equation of the parabolas. So parabola equation. Previously in this course, we studied parabolic graphs as the graphs of the quadratic function. As a graph of functions, the vertical line test limited our discussion to parabola that opens up and then down. In this section, we will be using a geometry definition while discussing parabolas, resulting in a general definition that allows for a parabola to open in any direction, which means it could be open up, it could be opens down, open to the right, and then open to the left. Okay, so we'll see the four different directions. However, we will limit our discussion to parabola that can open only the left, right, up, and down. Of course, we can think about this way too, as a diagonal way too. Okay, but we're not going to talk about it in here. So the definition of the parabola is the set of all points in a plane equidistant from a fixed line called the directrix and a fixed point called the focus. So this is it. So let's say, so instead of the center that we used to call the for the circle and ellipse and hyperbola, we're gonna call the vertex. So let's say vertex is the origin, and then if there's actually the directrix line here, and then which is this is a distance. So you need to go the same distance, and then you can see the focus right here, or other ways, which means this is the distance of the p units, and then wherever you have a parabola, you get the same distance as here to here, which is I have to go a little down, right? And then same here too. So if I about here, and distance has to be same as this distance. So when you're dropping the directrix, you have to have a 90-degree, and then this is your parabola. So we're gonna graph in little different ways, right? So we use the vertex with two other points, but this time we are using the length of p. So as example above the fix, we will study the parabolas using the vertex and directrix and a focus. However, despite the general definition which has no limitation on the directrix, will limit the directrix to either a vertical or a horizontal line, resulting in parabolas that can be opened in one of four directions, which is left, right, up, and down. So we're not going to think about other ways, okay? All right, so next page. The list of the components involved with the parabola will include the following. So directrix is a vertical, could be vertical or horizontal line. And then focus is a point not on the directrix. And the vertex, the midpoint of the horizontal vertical segment connecting the focus and the directrix. So again, concerning the text, we can derive the following standard equation of the parabola. So this is thing. So well, this is gonna be the left and right for the when the y is a square, and then it's gonna be open or down when x is a square. Okay, so that's what I recognize. So we will use as a standard form. So graphing parabolas. We will focus our initial discussion of the graphing parabolas with determining the vertex and the direction in which a given parabola opens. First, when determining the vertex, make sure that the x-coordinates is always a value in standard equation that is associated with the value of x, while the y-coordinates is always a value associated with the variable y. Secondly, the direction in which parabola open depends on the two characteristics. We must consider which variable is square, That's what I was talking about, right? Is it x squared or y squared, whether the value of the p is a positive or negative. If we recall our previously study quadratic function, the variable square was x and the parabola opens up and down. Therefore, the equation with the x squared continued to be the parabola opens up and down. Equation with the y squared, parabola is always the left or right. Okay, so it's the same as what we had before. So then, considering the sign of the value p, we have the following four possibilities. So there's an x squared, which is a positive. Positive means opens out. X squared negative down. Y squared positive right, and the y squared negative and the left. So we can now determine the vertex and direction that a parabola opens by using this chart above along with the two standard form of the equation of the parabola. So y minus k squared equal to 4p times x minus h, and then x minus h squared equal to 4p times y minus k. So vertex, of course, is a vertex, becomes h and k. All right, so determine the vertex and the direction of each following parabola. So the vertex is always from the x and y, but there's no actual shifting here, so just the x and y we have. So 0, 0 this side. And then the y is a square, so it's going to be up or down. It's going to be the right or left, but since there's a negative, so it's going to be the direction is left. Okay, for the b, the vertex is h is a negative 2 and the y is a 1. So from here, right? You know that, right? And then since x is a square and then 12 is a positive, so it's going to be the up. And then the vertex for the third, which is h is a negative 2, k is a 3, because 2 and negative 2 and 3 right there. And then y is a square, which is a right or a left, but 6 is a positive, so it's going to be a right. Okay, so you can just use a table to check it out. All right, let's go to the next page. In general, using the two standard forms of the equation of the parabola, which is I already introduced, and this is how you're graphing a parabola, okay? So determine the vertex, which is h and k. Determine the value p, that the direction that the parabola opens. Determine the focus and directress of both the distance of p from the vertex. Determine the width of the parabola and draw the curve. All right, so example 1, which is we already find the vertex, and then but this time we have to find the vertex and then focus and then directress, okay? And then of course we have to graph that too. So vertex was 0, 0. Okay, so this is a vertex. And then we have to find we have to actually find the p first, okay? So which means it's going to be the y square of 4px. Which means the matching the number, which is in the 4p, must be the same as negative 8. So if you set up the 4p equal to negative 8, and then solve for p, so p is a negative 2. So this one was the direction was a left, right? Because y squared and then with a negative and negative 8. All right, so you need to go to 2 units to the left. So this is the place of the focus, which means you have to go to 2 units to the right from the vertex, which is from the vertex 2 units to the right, 1 and 2. So this place, and then this is gonna be the directress. Okay. And then another important thing is actually you have to actually make it nicely as, okay, so from the focus, actually this is a p, which is the negative 2, or p is always, you can just consider as a positive length, okay, which is a 2. So from the focus, now you need to make a doubles of the p, which is a 4, isn't it? So from the focus, you go to 1, 2, 3, 4, which is 1, 2, 3, 4 right here. And then go to the down 2. So you go to 4 units to down from 1, 2, 3, 4, which is 1, 2, 3, 4, right here. And then this is how you graph. Okay, so this length becomes a 4p, which means half of it is going to be a 2p plane. So that's how you find out the two other points from the parabola. So now mentions labeling the focus. So this is the focus place and this is the directrix. Okay, so directrix is actually the x equal to 2. And then the focus is in here is going to be the -2 and 0. All right, next one. Okay, so this is x is a square, so it's going to be up, right? So vertex, which is -2 and 1, and goes up, right? And then we need to find the p. So this is actually you need to say as the number that you see as a 12, okay? So you can just set up the 4p is a 12. So p is actually the 3. So from the -2 and 1, which is right here, and then you need to, so this is a vertex, right? So you need to go up to get to the focus, okay? So 1, 2, 3 right here. So this is the focus. And then go down from the vertex to the 3 units, so 1, 2, 3, and then this becomes a directrix. And then in order to get the nice graph, you have to actually, so since this is a 3, right? So I need to go to 6 to the right and 6 to the left from the focus, okay? So 1, 2, 3, 4, 5, 6. To the left, 1, 2, 3, 4, 5, and 6, okay? And then this is a parabola that you're looking for. So that's a parabola. Okay, so which is a directrix is time is a y equal to -2. The focus we have is -2n and 1, 2, 3, 4. So 4. Okay, all right, go to the next one. So graph the parabola x squared plus 8y plus 8 equal to 0, labeling the vertex, focus, directrix, and the endpoints of the latus rectum. Okay, so which is I already show you how to do this. Okay, so the pointed from the focus to the on the graph we call the endpoints of the latus rectum. So all right, so but this time we need to make the standard form. So x squared plus 8y plus 8 equal to 0. So I'm going to leave the x squared on the left and then subtract the 8y both sides. Subtract the 8 both sides. I got -8y minus 8. And then x squared. And then I need to factor out the -8 because I need to keep the 1y. And then this becomes plus 1. So we have a standard form, which means right away we can find the vertex. So vertex is 0 and -1 because 0 from the x squared and then the -1 from the y plus 1. So from that vertex and then the 4p should be -8 and then divided by 4, -2. But x is a square, so it goes down because of -8. So from the vertex 0, -1, and then you need to go down to get to the focus 2 units. Okay, so from the vertex you go 1, 2, which is this is a focus, and then you go up to 1, 2, and then you get the directrix right there. And then the endpoint of the rectus rectum, we have to see the distance between the vertex to the focus is 2. So now you need to go to 2 units right to get the endpoints. So 1, 2, 3, 4. 1, 2, 3, 4 from the focus. And then here's your parabola. Okay. So next one, example 3. Graph the parabola y squared minus 16x minus 4y plus 20 equal to 0, labeling the vertex, focus, directrix, and the endpoints of the lactus rectum. So I'm going to rewrite the problem. So y squared minus 16x minus 4y plus 20 equal to 0. So I'll do the similar way the example 2. So I'll keep the y squared minus 4y and then move the 16x to the right, move the 20 to the right. Then I get the 16x minus 20. Okay, and then I need to complete the square. So y squared minus 4y. So I need a plus 4 to get the complete square, which is 16x minus 20 plus 4. Gotta adding the 4 both sides. Now left side becomes y minus 2 squared. And then the right side, you got the minus 16. And then in order to get a vertex, you need to factor the 16 because I need to get the inside the x as a 1. So x minus 1. Alright, so we are ready to tell the vertex. So vertex in here is going to be 1 and 2. And then for p is 16, which is a p is a 4. So this is a y squared, so it goes to the right. So from 1 and 2 right here, which is a vertex, and then you need to go 4 units to get to the focus, okay? So from the vertex, you need to go 1, 2, 3, 4 right here. So that's a focus. You need to get the 4 units to the left to get the directrix. So 1, 2, 3, 4 right here. So this is a directrix line. But since the distance between the vertex and focus of 4, now you need to go 8 to get the endpoints of the rectus tarantum from the focus, okay? So from the focus, I go 1, 2, 3, 4, 5, 6, 7, 8. Whoa. Down to 1, 2, 3, 4, 5, 6, 7, and 8 right there. And then this is your parabola. So it's not bad, right? To graph this. Alright, next page. Find the equation of parabola. As with every section in this chapter, the final topic in this section will contain questions that ask for the equation of a graph that has a specific qualities. So example 4, find the standard form of the equation of the parabola has a vertex of 3 and negative 1 and then focus of 0 and negative 1. So first of all, I want to have a rough graph to get the equation, okay? So vertex is a 3 and negative 1 right here. So that's a vertex. And the focus is 0 and negative 1, which is right here. So this is a vertex, this is a focus. Which means your graph is going to be something like this. Oh, so it goes to the left, right? So I'll write the standard form as y minus k squared, because it's go to right or left, you have to say y squared, right? And then for p of x minus h. So this formulas I'm going to use. I know the h and k because the vertex says h and k, right? So I got y minus negative 1 is plus 1 squared. And then for p of x minus 3. Now we have to find the p, but p is the distance from the vertex to the focus, right? So I believe this is 3 units away, right? So p is a 3. So you just plug it in. So you got y plus 1 squared. And then p is a 3 because p is a distance from the vertex to the focus, okay? And x minus 3. Then you got y plus 1 squared. And 4 times 3 is a 12 of x minus 3. So this is the equation you have. Example 5. To find the standard form of the equation of the parabola has a directrix this time. Directrix is y equal to negative 5. And then focus is negative 2 and negative 1. Okay, so yeah, I want to do the love graph. Which is focus is a negative 2 and negative 1 right here. And directrix is a y equal to negative 5, so 2, 3, 4, 5. Okay, so you have to actually to go to the 4 units to get the focus from the going up. Okay, so from the vertex you go 1, 2, 3, 4. Okay, and then this is the place of focus, so you graph something like this. Okay, so my standard form is going to be x minus h squared equal to 4p of y minus k. Okay, we don't have a vertex this time, so we have to find it. But oh, sorry about that. My graph is wrong. Okay. Hold on. I used the focus as a vertex. Okay. Yeah, I got the right one though. Okay, so let me redo the example fine. So yep, yeah. Sorry. So which means on this here on the plane, you got -2 and -1. But this is a focus. So what am I talking about, right? Okay, and then 2, 3, 4, 5, and this is directress. So the in order to get to the vertex is a right midpoint between the directress and then the focus. So units between the focus and the directress is actually 1, 2, 3, 4. So 4 units. So if you go down, so half of 4 is a 2. So if you go down to 2 units, and then this should be the place of the vertex. Okay, so the vertex will be the -2, but you need to down 2 unit from the -1, so -3. So this is actually the vertex. And then your parabola goes this way. Okay, and then so it's going to be up, so we have to put x minus h squared equal to 4p times of y minus k. So the x minus -2 plus 2 squared, 4p of y minus -3 plus 3. And then distance between the focus and vertex is actually the 2, right? Do you see the 2 here? Okay, so p is a 2 this time. So you got x plus 2 squared, 4 times up 2 times y plus 3. You got x plus 2 squared equal to 8 times y plus 3. So this is the final answer. Okay, all right. So that's all for the parabola. So as you noticed, then it looked different than what we used to graphing the parabola. Thank you for listening.